CO2 and bicarbonate levels. And I'm just going to, again, just, just write them without putting the answers in yet.
Can you leave this while you use the restroom? Thank you.
Okay? And so we're going to put up down, but again, I'm going to show you where memorizing that I think might be useless versus trying to figure it out. So, there's going to be 3 clues. Okay, I'm going to put the 3 clues and then practice. One is, if you have a respiratory, one of these, basically, all 3 of these, remember the 3 I'm talking about, will make sense, will follow the law of mass action, which is what we did before. And we'll practice that. So that's going to be one clue. The second clue is, if you have alkalosis, if you have okay, that's respiratory. I guess, and I don't know if I want to write these clues down right now or something, maybe I will. I'll wait maybe. Yeah, maybe I should actually demonstrate and then we'll see it and then I'll write the other things that will fit in. But I'll demonstrate that first one. So now does everyone sort of get the idea so far? You have this idea where you can definitely diagnose from the hydrogen levels whether you have acidosis or alkalosis. And now we're going to figure out these other ones. Okay? Now, the reason I said respiratory ones are easy is because we can do what we did before early on in class. Okay? And that's where we can basically follow law of mass action but include bicarbonate. So if we did hypoventilation, okay, and we just follow like we did before, what happened? Okay, hypoventilation caused what? What is the cause over there on that side of the equation?
High CO2.
High CO2. Okay? High CO2 caused what? Law of mass action.
Goes right.
Which caused what?
High H.
Okay, but what we didn't say before is, if you're going this direction, it's not just one product that goes up, does it?
No.
Both products go up. So not only do we have high hydrogen, we have high CO2, high bicarbonate. That's characteristic of respiratory acidosis. Okay? So that follows directly, right? The only thing we didn't do that we did at the beginning of class, or that we didn't do at the beginning of class, was go ahead and finish off with that, okay, bicarbonate. We said this went up and that caused it, but we didn't say that. But that's law of mass action stuff, right? Okay? Same thing if we just did, let's do hyperventilation, just get those out of the way to show you, those will make sense. All you have to do is sort of follow what we did before. So, again, you hyperventilated, and that caused CO2 to be what?
Go down.
Okay, so we got that value. And then if we have CO2 goes down, we have what?
The law of mass action is
And what happens here?
hydrogen goes down,
And so does bicarbonate. Both of these are converted. So we have, and so again, we already had low hydrogen up here, but now we know from respiratory, they both go down. So those fit. I mean, you can either memorize that if you want, but then you can reverse it. You could just kind of do what we did up there and you'll get those. Now we're going to see metabolic. And that's what's going to be a little different. Okay, and those are going to be the 2 things we're going to see on this. So I can erase this, right? We're doing metabolic. Let's do the 2 metabolic ones to show you how we'll get this. Metabolic, remember, we're starting on the other side. Okay, so the first thing on the metabolic is the following. Let's say we have, again, you can say vomiting or whatever, but whenever we talked about having low hydrogen, what was that in general? Acidosis or alkalosis?
Alkalosis.
Alkalosis. this is the key. You know, because I just didn't, you know, we don't go through everything through this course. You know, not only is a loss of hydrogen alkalosis, but an increase in bicarbonate. We're pretty big on controlling bicarbonate levels. The kidney as well. I just skipped that. Can't do everything. Excuse me, on the kidney. But you associate that. Remember that now we're used to this up-down arrow, right? So you know, if we're starting on the metabolic side, which is what we're doing now, right? We're starting on the metabolic side. You want to put both these values, okay? Now, and so then again, if you just follow this, and this will be, you know, kind of as we do it. So again, let's say we have, again, that's number one. If we're losing hydrogen, we're still paying attention to that. If we're losing hydrogen, law of mass action takes us where?
To the right.
And therefore CO2 is, okay, if we go this way, CO2 goes
Down.
down. But what do we say that then happens?
The respiratory response.
Your respiratory is going to respond by doing what to respiration?
Increase.
So we decrease respiration, and because it is so fast, when you actually are monitoring, you actually will see an increase in CO2. So that's why the respiratory system, when you do a metabolic, responds and actually will reverse the CO2 from the law of mass action. That's why the respiratory problems are easy, right? You just do it. This one, you just have to remember that it reverses. And so this was respiratory, this was metabolic alkalosis, okay, right? Low hydrogen, and so it's high and high. If you do, okay, well I can actually, even before I do the fourth one, one of the tricks will be CO2 and bicarbonate will be the same. And we can fill it in we can even do that last one. But they are sort of working in the same direction every time. So once you determine one, you can usually basically, I mean, you might want to go ahead and continue to make sure, but you know, you're going to be able to determine the other one as well. But no matter what, they're either both going up or they're both going down. Again, memorizing this table, which you could do, I find, I would have a headache trying to do it. I can't memorize that table. So I just kind of work it out this way in practice. So from that idea, if we did, right away, if we did metabolic acidosis, we're saying acidosis is what? Low or high hydrogen?
Hi.
Which means what for bicarbonate? Right? Remember, they're always going to work opposite. If we know it's low bicarbonate, what else do we know? As far as CO2? Low. Okay, and I'll show you how, but remember, I just said they will always go together. Okay? If you want to follow it, again, high hydrogen means law of mass action goes, if you have a lot of hydrogen, you go this way, right?
Yep.
CO2 goes respiratory says increase respiration, and therefore by overcompensating,
We need to decrease CO2.
which is what I said there. So the thing, that's why that clue can kind of help you once you get one. You don't have to work out all the steps. It's not an essay question that you have to work out the steps too. It was down, down. But if you understand this, it'll make it a little bit easier to get those questions. Again, 2 questions are going to be on the test. I'm going to give you, you have, one of these 4. Patient has metabolic acidosis. What are the corresponding levels of these? And I'll have combinations, up, up, down, 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 up. And obviously you need to know which one it is by doing the problem. Otherwise, I'll be giving you have a patient with high, high, low, and then you have to diagnose the condition, which will be just the same thing, basically. Again, I wouldn't memorize the chart at all. I would just practice a little bit with just doing it and just sort of reproducing them, and you can basically know. The easiest ones being, well, it depends. I mean, you might consider this, once you do this step, if it's metabolic, you actually have the answer. You don't even have to do these, right? because you know this is always reverse, okay, from one another, and you know carbon dioxide will follow that as well. That's why you don't really have to do the whole law of mass action. The respiratory ones, you just do the law of mass action like we did and just include bicarbonate. So, you know, it's a little confusing until you practice it, but again, I think it's really important because this is really, you know, what they do when you actually have a patient. One of the main, at least what they tell me from the book, okay, I don't know real life, maybe they don't do any of this, but from this book I went through, they're looking at these 3 levels, and by these different combinations, they can now determine, basically, unless you have a mixed condition, what you actually have. That's what you get to do on this test too. This is your big clinical test, okay, between the kidney and this, kind of the major stuff. So this and this, you know, you can memorize that chart, but I think it's sort of ridiculous to sort of memorize it. I'd have trouble doing it, but maybe, you know, you guys have tricks to memorize it. So if you can memorize anatomy, that's probably like a piece of cake. Any questions?
Oh, yeah.
Okay, that's my main lecture summary of most things.